What makes shadows on the moon? The moon is the brightest object in the night sky. We only see the moon because it reflects light coming from the sun. Our nearest neighbour can often look smooth and featureless, but it is in fact covered in mountains and craters. Features like these stand high above their surroundings and cast shadows across the surface. These shadows change with time as the angle between the sun and the moon changes. The moon is always moving. It completes an orbit of the Earth every 27.3 days, and together with the Earth, it orbits the sun. At any given point in the moon's path around the Earth, only half of its surface is facing the sun, and therefore only half of the moon is lit up. The other half of the surface faces away from the sun and is in shadow. It takes about the same amount of time for the moon to rotate on its axis as it does to complete its orbit of the Earth, approximately 655 hours. So if you lived on the moon, you would experience 327.5 hours of sunlight, followed by 327.5 hours of darkness. As the amount of daytime moon we can see changes, we experience different phases of the moon. But how does this affect the shadows we see? We get the best view of shadows cast by features on the moon when looking near the terminator. This is the line that separates the part of the moon in the sunlight and in the dark. Near the terminator, the shadows are exaggerated by the larger angle between the sun and the local area, much like on Earth during sunrise and sunset. The shadows here also change relatively quickly. We have the best views of the terminator when the moon is in a quarter phase or a gibbous phase. At the new moon, the entire half of the moon facing the Earth is in shadow, so we can't see the individual shadows cast by the moon's features. At full moon, we are seeing the moon at the equivalent of noon. The sun is high overhead and casts short shadows on the moon, making them much harder to see. The best way to watch the shadows change on the moon is to pick a location near the terminator. Pick a tall feature like a mountain or a deep crater and make your observations during gibbous or quarter phases. Did you know scientists can get lots of useful information from the shadows on the moon? They can use changes in shadows to work out how steep crater walls are or how tall mountains are. This information helps to understand the moon's geology and to plan future missions. Working out where to expect shadows and sunlight and the general steepness or topography of the terrain is also important for lunar rovers or equipment that uses solar power. Some areas are always in shadow, and these may be the best places to find water ice on the moon. This could be used as drinking water for astronauts visiting the moon for long periods of time in the future. So next time you look at the moon, think about the shadows as well as the light.